explain and give the examples of trigonometric identities. Okay. The first one is ratio identities. Ratio identities describe the relationship for tangent, cotangent, secant, and cosecant in terms of sine and cosines as follow. The first one is tan theta is equivalent to sine theta over cosine theta. The second is cotangent theta is equivalent to cosine theta over sine theta. The next is cosecant theta is equivalent to 1 over sine theta. The last is secant theta is equivalent to 1 over cosine theta. The next is Pythagorean identities. These are probably the most significant identities since many of the existing identities use this as part of derivations. Okay, the first is sine squared plus cosine squared theta is equivalent to 1. 1 plus tan squared theta is equivalent to secant squared theta. 1 plus cotangent squared theta is equivalent to cotangent squared. The next is identities expressing trigonomic function in terms of their complements. You will notice in this identity that a certain trigonomic function is equal to its cofunction evaluated at the complementary angle. The first one is cosine theta is equivalent to sine parenthesis 90 degrees minus theta. The next is sine theta is equivalent to cosine 90 degrees minus theta. Next is cotangent tan times 90 degrees minus cotangent theta. Tan theta is equivalent to cotangent times 90 degrees minus cotangent. Next is cosecant theta is equivalent to secant 90 degrees minus theta. The last is secant theta is equivalent to cosecant times 90 degrees minus theta. The next is identities expressing trigonomic function in terms of their supplements. It is almost similar with the previous. However, you will notice here that the trigonometric function of an angle is just the same for its supplement, except for some function whose signs may be interchanged. Sine open and close parenthesis 180 degrees minus theta equals to sine theta. Cosine open and close parenthesis 180 degrees minus theta is equal to negative cosine theta. Tangent open and close parenthesis 180 degrees minus theta is equal to negative sine theta. Okay. Sine theta close and close parenthesis negative theta. By the way, this is the negative angle identities. Negative angle identities, sine, tangent, and cotangent are odd functions, while cosine and secant are even functions. That is why the negative angle of cosine is just the same as the positive angle. So, sine times theta is equivalent to negative sine theta. Cosine negative theta is equal to cosine theta. Tangent negative theta is equivalent to negative tan theta. The next is periodicity of trigonomic function. Cosine, sine, secant, and cosecant has a period of 2 pi, while tangent and cotangent has a period of pi. This means that cosine and the other stated function will complete one cycle after reaching 2 pi and will just repeat the same wave. Unlike tangent and cotangent, they will begin repeating the cycle after reaching pi. Sine, this is the sample. Sine, open and close parenthesis, theta plus 2 pi is equivalent to sine theta. Cosine, theta plus 2 pi is equivalent to cosine theta. The last is tan theta plus pi is equivalent to tangent theta. The next is Ptolemy's identities. The equation under these identities show the relationship of the trigonometric functions, value of the sum and difference of two angles with respect to the trigonometric function value of each angle, taken one at a time. Okay, this is the formulas. Sine times a plus b is equal to sine a cosine b plus cosine a sine b. The next is sine a minus b is equivalent to sine a cosine b minus cosine a sine b. Next is cosine, open and close parenthesis, a plus b is equal to cosine a cosine b minus sine a sine b. The last is cosine, open and close parenthesis, a minus b is equal to cosine a cosine b plus sine a sine b. The next is double angle identities. The double angle identities were derived from the Ptolemy's identities, sum and difference. Okay. Sine 2 theta equals 2 sine theta cosine theta. Next is cosine 2 theta is equivalent to cosine square theta minus sine square theta. Next is cosine 2 theta is equivalent to 2 cosine squared theta minus 1. Next is cosine 2 theta is equivalent to 1 minus 2 sine squared theta. The last is tangent is equal to 2 tan theta over 1 minus tan squared theta. The next is half angle identities. Half angle identities. The half angle identities were derived from the double angle identities. These are used in calculus for a particular kind of substitution in integrals called the Weierstrass T substitution. Okay. Sine equals to theta over 2 equals to positive negative square root of 1 minus cosine theta over 2. Next is cosine theta over 2 is equivalent to positive negative square root of 1 plus cosine theta over 2. The last is tan theta is equivalent to sine theta over 1 plus cosine theta equals 1 minus cosine theta over sine theta. The second to the last is product sum identities. These identities allow one to change a sum or difference of cosine or sine into a product of cosine and sine. Okay, the first is sine A plus sine B is equal to 2 sine, open close parenthesis, A plus B over 2 cosine A minus B over 2. The next is sine A minus sine B equals to 2 cosine, open and close parenthesis, A plus B over B. Sine B, open and close parenthesis, A minus B over 2. The next is cosine A plus cosine B is equal to 2 cosine, open and close parenthesis, A plus B over 2, cosine A minus B over 2. The last is cosine A minus cosine B equals to negative 2 sine, open and close parenthesis, A plus B over 2, sine A minus B over 2. The last identity is product identities. The product identities were used before logarithms were invented in order to perform multiplication. Okay. Sine A cosine B is equal to sine, open and close parenthesis, A plus B plus sine, open and close parenthesis, A minus B over 2. The next is cosine A cosine B is equal to cosine, open and close parenthesis, A plus B plus cosine A minus B over 2. The last is sine A sine B is equal to cosine, open and close parenthesis, A plus B minus cosine A minus B over 2. Okay. Thank you for listening. Thank you. Bye. This is the trigonometric identities.